Page 6 of HL Addendum for discrete random variables. Number 5. Consider a random variable that has a Poisson distribution and has a parameter m. So this m, remember, for Poisson distribution is used for mean and is used for sigma squared. And they didn't tell us what m is, so they're going to ask us what m is. Find m given that the probability that x equals 1 plus probability that x equals 2 is equal to the probability that x equals 3. That's interesting. Okay, so like the Poisson distribution is kind of shaped like this. It's like and then it gets big, and then it gets smaller, and then it kind of like fades off to infinity. Okay, and this will be 0, 1, etc. Right? So let's find m, given that this is true. Let's find the formula for Poisson distribution. If you remember, it is the probability that x equals x is equal to m to the x, e to the negative m, and x factorial. So let's write this expression for 1, 2, and 3, and then we'll set them equal to each other. Okay, so the probability that x equals 1 would be m to the first, e to the negative m, over 1 factorial, which is just 1. So that's probability of x equals 1. What's the probability that x equals 2? It's equal to m squared, e to the negative m, divided by 2 factorial, which is just 2. Finally, what's the probability of x equals 3? That's equal to m cubed, e to the negative m, divided by 3 factorial, which is 3 times 2 times 1, which is 6. Okay, now we would like to figure out what m is if probability of x plus probability of x equals 1 plus the probability x equals 2 is equal to the probability of x equals 3. So what we're going to do is we're going to add these two together and make it equal to that. So m e to the negative m plus m squared e to the negative m divided by 2 equals m cubed e to the negative m divided by 6. So I'm going to divide everything by e to the negative m, and I get rid of that complicating factor. And then I'm going to get rid of one of the m's. So So what I'm going to have here is 1 plus m over 2 equals m squared over 6. And now I'm going to get a quadratic, so I'm going to subtract everything to the right side. So I'm going to have m squared divided by 6 minus m divided by 2 minus 1. And then I'm going to multiply everything by 6, so I don't have that 6 in the denominator, which is kind of annoying. M squared minus 3m minus 6. Now I'm going to factor. This is a job for poly SMLT. Put 1, put negative 3, and put negative 6 in for the coefficients. Press solve, and we get these two possible values of m, but m, which is the mean value of the random variable x, obviously can't be negative, because otherwise there are no values of x which are negative. It's 0 to whatever. So it should be 4.37 is the solution. So m equals 4.37. So that's the answer to A. B, if m equals 2.7, find the probability that x is greater than or equal to 3. Okay, this is a job for the calculator. So we're going to go to distribution. Oops, let's get out of this first. Quit, second distribution, and we're going to go down to the distribution Poisson CDF, right? Why CDF? Because we want to calculate greater than or equal to 3, which is, you know, a large section of this. If we're going to calculate a large section, we should use CDF, not PDF. PDF only calculates 1 bar. So we're going to do CDF, and our lambda value is, what they're talking about is m, so we're going to put 2.7. And then for the x value, we're not going to actually put 3, because 3 is greater than or equal to 3. The distribution, Poisson CDF distribution function on the calculator calculates less than or equal to something. So if we want to find out the probability of the interval greater than or equal to 3, we're going to find the probability of less than or equal to 2 and subtract that from 1. So we're going to put 2 and figure that out, and that gives us 0.494, and then we're going to subtract it from 1. So 1 minus that is what we want, 0.506. Okay, so probability that x is greater than or equal to 3 in this case is 0.506. 0.506. Okay, and then I'm going to look at part 2 here. So we got the probability of x is less than or equal to 4, given that x is greater than or equal to 2. So if you remember, what you need to do is you need to find the probability that x is between, it's like when you have the probability of A given B, that's equal to the probability of A intersect B divided by the probability of B. So the top is going to be the probability that x is between 2 and 4. And the denominator is going to be the probability that x is greater than or equal to 2. Okay? All right. So let's continue that here. So the probability that x is between 2 and 4 would be the probability, since the calculator can only do probability of x is less than or equal to something, that would be equal to the probability that x is less than or equal to 4 minus the probability that x is less than or equal to 1. If we subtract that, that will give us exactly the probability between 2 and 4. And then we divide that by the probability that x is greater than or equal to 2. The calculator can't do that. The calculator can figure out less than or equal to 1. So we'll do, the bottom will be probability 1 minus the probability that x is less than or equal to 1. So let's figure out some of these. So we got probability is x is less than or equal to 1. That one we definitely need. So second distribution, and we go down to binomial, no, not binomial, Poisson CDF, and then we put in 2.7, which is the m value they gave us, and 1, less than or equal to 1, and we find out that's 0.249. So every time we see x is less than or equal to 1, we can substitute 0.249. And x is less than or equal to 4, we can put 4 here. We get 0.863. And then we can subtract those two. We get the numerator 0.614, and the denominator would be 1 minus 0.249, which would be 0.751. And so if I divide 0.619 or 0.614 divided by 0.751, the probability is 0.818. 8. Okay? That was a little bit of conditional probability mixed with Poisson distribution. Okay, number 7. Road safety figures for a large city show that any driver has a 0.02% chance of being killed each time he or she drives a car. Use the Poisson approximation to the binomial distribution to find the probability that a driver can use a car 10 times a week for a year and survive. Okay, so what do they mean by the Poisson approximation to the binomial distribution? Okay, so if we were going to do this with binomial distribution, we would say that the number of trials is 10 times 52 weeks a year, 520, and the number of x's desired would be 0. We don't want the person to die. And the probability on any trial that they would die, any outing, they have a 0.0002 chance of dying. So if you put this into binomial PDF, you could find the probability using binomial distribution. They want to find the same probability using the Poisson distribution. So what you do here is you need to figure out what the lambda value or the m value is. So in this case, what you want is the expected number of times a person would die during the year. So that would be 0.000. So the person goes out 520 times a year, and they have a 0.0002 chance of dying. So the expected number of times they would die would be 520 times 0.0002, 0.104 times a year. Okay, so you remember that Poisson distribution is always calculating on based on a certain time period. In this case, it's a year. Okay, and so we can use the Poisson distribution with lambda equals 0.104 to figure out what is the probability that you will not die during the year. Okay, and then you're like, well, where do I input the fact that it's 1 year? You don't have to, because your 0.104 is calculated based on 1 year. So it's already kind of in there. So Poisson, in this case, we can use PDF because we only want to find when x equals 0. And we put 0.104, which is the average number of times, or the expected number of times you would die in a year based on the probability we were given. And we want to die 0 times. So it's 0.901. I did this calculation also, and it comes out very close to 0.901. Okay. B, if this data does not change, for how many years can you drive in the city and still have a better than even chance of surviving? So let's just give an example. Let's say that you go 10 years and you want to calculate what's the probability that you are going to survive by driving at this rate for 10 years. So for 1 year, it would be 0.901. So for 10 years, you would just multiply 0.901 times itself 10 times to find the probability that you could survive 10 years. Okay. Now what they want to know is, how many years do you need to survive, or how many years would you go by so that your probability of surviving would be 50%. Okay, better than even chance. So actually they want it to be better than 50%. So they want it to be greater than or equal to 0.5. But basically to do that, we need to solve for 0.901, number of years, equals 0.5. So we need to somehow analyze x as a base and not an exponent. And remember, the way we do that is we take the log of both sides. If we take the log of both sides, we'll get x log of 0.901 is equal to the log of 0.5. So x equals the log of 0.5 divided by the log of 0.901. And it turns out here it is. Log of 0.5 divided by log of 0.901 is 6.65 years. Wow, you can only, if you drive 6.65 years, you already have a 50% chance of dying. That's pretty bad. The random variable y has a Poisson distribution with mean m and satisfies the equation probability y equals 3 equals probability that y equals 1 plus 2 times the probability that y equals 2. These are like clever little ways of forcing you not to use the calculator, because if they do give you a value for m, you can already use the calculator. They want you to use the formula. So we're going to use the formula here. Since we don't know what m is, we're going to have to use x equals 3, x equals 1, x equals 2 to write out kind of a big equation, and then we're going to have to probably use algebra to solve that. So for the first one, we're going to put m, because we don't know what m is, to the third e to the negative m divided by 3 factorial equals m to the first e to the negative m divided by 1 factorial, which is just 1, plus 2 times the probability that y equals 2. That would be m to the m squared e to the negative m divided by 2 factorial, which is 2. So 3 factorial, remember, is 6. And we can cross out all the e to the negative m's because we could just divide everything by e to the negative m. And now we could make a polynomial out of this. Let's first multiply everything by 6 so that we don't have anything in the denominator anymore. So I have m cubed equals 6m plus, and the 2's cancel out here, so this will be 6m squared. And now let's put everything on the left side. So we have m cubed minus 6m squared minus 6m equals 0. And now we're finding different possible values of m. First, factor out nm, so we have m squared minus 6m minus 6 remaining. And we'll use poly-SMLT to solve that because I don't think it's easily factorable from what I see. So poly root finder, next, and so our coefficients are 1, negative 6, and negative 6. So 1, negative 6, and negative 6, and we do solve. And we have 6.87, and we have a negative number, which we can ignore because m has to be positive. So 6.87 is our value for m. Okay. For 4 decimal places. To 4 decimal places. So 6.8730. Right? Okay. Part B. Hence find the probability that y is between 1 and 5, not including 1 and 5. So now this is, pretty much a calculator problem. We could do the probability that y is between 1 and 5, not including 1 and 5, is equal to the probability that y is less than or equal to 4 minus the probability that x is equal to 0, right? That would, equal to, minus the probability that x is less than or equal to 1. Okay? So that's true, right? And then I'm just going to use a calculator. I'm going to do the Poisson CDF function, and I'm going to put 6.873 as our lambda or m, and I'm going to put 4 first, and that gives us that. And now I'm just going to repeat it, and I'm going to put 1, and then I'm going to subtract 1 from the other. So this minus this. 0.176 0.7, okay? All right, so that was part 1 there. And then let's do this one here. Oh, this is conditional probability again. So the probability that y is between 2 and 6 inclusive, given that y is greater than or equal to 4. So what we want to do is remember that probability A given B is equal to the probability that A intersect B divided by the probability of B. So the probability of B is pretty straightforward. It's probability that y is greater than or equal to 4. Okay. On the top, we need to intersect these two. So the probability that y is between 2 and 6 and the probability that y is greater than or equal to 4 means the probability that y is between, probability that y is between 4 and 6. Okay, because 2 and 3 is not part of probability of B, so we don't need that. So that's equal to the probability that y is less than or equal to 6 minus the probability that y is less than or equal to 3, okay, divided by the probability that y is greater than or equal to 4. Now remember, probability that y is greater than or equal to 4 cannot be calculated by the calculator. It only calculates less than. So we're going to change that to 1 minus the probability that x or y is less than or equal to 3. And does that work now? Okay, yeah, I think it does. So let's figure out what the probability for 3 is and what the probability is for 6. And we'll just plug them in. So for 6, it would be 0.469. So instead of y is less than or equal to 6, we're going to put 0.469. And then probability y is less than or equal to 3. The probability is 0.0886. And 1 minus 0.0886. Okay. So let's see. So we're going to have y is less than or equal to 6, which is 0.469, minus y is less than or equal to 3, which is 0.0886, and we're going to divide it by 1 minus 0.0886. And the answer is 0.417. Okay, that's it.